In lesson 6.4, we're going to look at what happens to parent functions as you translate or move them around. It says, use a graphing calculator, start with the standard viewing window, which you can obtain by pressing all of those buttons. If you don't have a graphing calculator at home, there are several apps that you can use for the following lessons. There are several that appear to behave similarly to the ones we used in class. If you have an Android, this is similar to the TI-84, or if you have an iPhone, there's one called Calculate 84. So it should have the same buttons as the calculator we used in class, so all of these descriptions in the lessons should match what the functions on your calculator are. I am using the app, so when you hit window, it will show you that the x goes from negative 16.1 approximately to positive 16.1. And the y values go from negative 10 to 10. It says graph the function f of x equals x by pressing the y equals button on your calculator and entering the function's rule next to y1. There is a button on the calculator which has an x, a t, a theta, and an n. You're going to push that to get the variable. Then you can hit the graph button and it will take you over to the graph of the line. And it says, what is the slope and y-intercept of this graph? The slope is 1 and the y-intercept is 0. Now it says graph other functions in the form f of x equals x plus b by entering the rules into y2 and y3. So you're going to go back to the y equals button in the top left and then go down to y2 and you'll type in that x button again and add some other b value in there. Then do the same thing in y equals 3. Hit that x button and maybe this time use a minus for your, or a negative for your b value. And then to view those, you're going to hit the graph button in the top right corner again. It says, what do the graphs have in common? All of these graphs have the same slope. The piece that is different about them is their y-intercept. A vertical translation moves all points on a figure the same distance, either up or down. Use the idea of a vertical translation to describe what happens to the graph of f of x equals x plus b when you increase the value of b and decrease the value of b. By increasing the value of b, you move the line up. Decreasing it would shift it down. In this Explore, we replace the linear function f of x by f of x plus k. Show how replacing f of x by x plus k has exactly the same effect. So if we took f of x equals x and we add k to the end, then over here we have to add k to the end. If we took f of x equals x, and we replaced the x with the number x plus k, then in this situation we would replace the x with x plus k, which is exactly the same thing. Now we're going to use a graphing calculator again. Press the y equals and clear out all of the things before. That clear button is over on the right side underneath the arrows. Now we are going to put in a function that has a slope other than 1. So it says use only values of m that are greater than 1. So we can just use the two examples that it gives us. We'll type in 2x, and then in y2 we can type in 6x. And then if you hit the graph button on the right side, it shows us the two graphs. These both have the same y-intercept, but they have different slopes. It says, as the value of m increases from 1, does the graph become steeper or less steep? The higher that m value gets, the steeper it becomes. Again, press y equals and clear out all the functions. This time we are going to have slopes that are between 0 and 1. So we have 0.2x and 0.5x. And then hit that graph button. It says, as the value of m decreases from 1 to 0, does the graph become more steep or less steep? And it actually becomes less steep. The closer it gets to 0, the flatter it becomes. Then it says, clear out those two things again. And this time we have negative x. The negative button is right there next to the equals or enter button on the bottom. And the regular x. It says, what are the slope and y-intercept of the graph? The slope is -1, and the y-intercept is 0. How are these graphs related? This is a reflection of the parent graph. Again, press y equals and clear out those two things. Now we are going to enter negative x in the y1 line. In the y2 line, it says to use something that is less than -1. So I'm going to use -4x. And in the y3 line, it says to use a slope that's between -1 and 0. So I will use -0.2x. You can pick other numbers, but we're just trying to get an idea of what's happening with these lines. Then click the graph button so you can view those lines. And it says, describe what happens to the graph as the value of m decreases from -1. So if we're looking at this line where it's y equals -4x, what's occurring? The farther from -1, or the more it decreases from -1, the steeper it gets. Slopes between -1 and 0 are less steep. The closer it gets to 0, the less steep it is. When m is greater than 1, will the graph of f of x equals mx be a vertical stretch or a vertical shrink of the graph with the parent function f of x equals x? So what it's talking about is if we had a line and we grabbed both endpoints of the line, if we stretch them, then the points are going to get farther and farther apart. But if we shrink them, the points are going to get closer together. So a vertical stretch would have a steeper slope, and then a vertical shrink would be less steep. So with m being bigger than 1, that would be slopes like 2, 3, 4, 5, and so on. They're getting larger than 1. This would be a vertical stretch because it gets steeper. If the slope is between 0 and 1, such as 0.5, 0.2, 0.13, those are going to be a vertical shrink. Because it's less steep. Investigate what happens to the graph of f of x equals mx when you change the value of m. A says a family of functions is a set of functions or equations whose graphs have basic characteristics in common. What do these variations of the original function, f of x equals x, have in common? So we're looking at these two things. What do they have in common? Well, we know in this one the slope is 1, but over here the slope can be anything. But they both have the same y-intercept of 0. B says the most basic function of a family of functions is called the parent function. What is the parent function of the family of functions explored in the first two explore activities? We looked at that parent function, f of x equals x, and we changed the slope and we changed the y-intercept, but the basic piece that we started with, the components we started with, was that f of x equals x. If you're like, Mrs. Stocks, I'm still stuck on what that f of x is, it's just a replacement for y. So up here, this would be like y equals mx. All right, then in C, it says a parameter is one of the constants in a function or equation that determines which variation of the parent functions one is considering. What things can we change about the original function to create new functions? So it says for functions in the form f of x equals mx plus b, what are the two parameters? Well, we can change the m and we can change the b, which both of those are the slope and the y-intercept. For the family of all linear functions, the parent function is f of x equals x, where the parameters are m equals 1 and b equals 0. Other examples of families of linear functions are shown below. The example on the left shows a family with the same parameter m, so all the slopes are the same, and differing parameters b. The y-intercepts are in different spots. The example on the right shows a family where they have the same parameter b, all of them cross at the same point on the y-axis, but they have different slopes. Describe a parameter that is left unchanged in the equation of the lines in the first graph. The slope remained the same. You can see right here, m remains the same in all of them. So m was 2 for all of the equations in the first graph. Then it says interpreting parameter changes in linear models. Many real-world scenarios can be modeled by linear functions. Changes in a particular scenario can be analyzed by making changes in the corresponding parameters of the linear function. So now we're working with some like word problems. It says a gym charges a one-time new member fee of $50. That's like an initial value of B. And then a monthly membership fee of $25. Since that's monthly and it happens repeatedly, that's going to be our slope. That's our constant rate. The total cost C of being a member of the gym is given by the function C, the function of T, equals 25T plus 50. T is the time in months since joining the gym. For each situation below, described below, sketch a graph using the given graph of C of D equals 25T plus 50 as a reference. So it says the gym decreases the one-time fee for new members. What change did you make to the graph to represent a lower one-time fee? We would need to reduce the slope or the y-intercept if we're changing the one-time fee. We would have to decrease the y-intercept. So an example of that might be maybe if they made it $25, it would still have the same slope, so it should be parallel, but it's going to be below. It says I decrease the y-intercept, but the slope remains the same, so you can see they drew that there. In B, it says, the gym increases its monthly membership fee. What change did you make to the graph to represent an increased monthly fee? We would have to increase the slope. So then it might look something like this. It still has the same y-intercept. That new membership fee still is $50, but the monthly fee is going to be more expensive. Now, it could be any of those steeper than the line that's already there. 5. Suppose the gym increases its one-time new member fee and decreases its monthly membership fee. Describe how you would alter the graph to illustrate the new cost function. So if they increase the one-time member fee, we would increase the B value, also known as the y-intercept, and they decreased its monthly membership fee. So we need to decrease the slope, also known as M. And that would make it less steep if they decrease the membership fee. Determine what will happen to each parent function when the described changes occur. Once a year, the gym offers a special in which the one-time fee for joining is waived for new members. What impact does this special offer have on the graph of the original function? C of t equals 25t plus 50. So if it is waived, the one-time fee is waived. That means they do not have to pay it. So it would reduce or decrease the y-intercept, the b value, to 0. So our function would say C of t is 25t plus 0. Suppose the gym increases its one-time joining fee and decreases its monthly membership fee. Does this have any impact on the domain of the function? The domain is the values that you can use as inputs. So, no, the domain remains the same. we would still want to have t be a positive number. You could have 0 months, or it could be more than 0. You could also write it as t is greater than or equal to 0, either one of those directions. Does this have any impact on the range of the function? So the range is the outputs. And yes, it does impact the outputs. If before we could have outputs as low as $50, but then they increase the one-time fee, then C of t couldn't be 50. It would have to be whatever the new amount is. The new joining fee. So this was before, and this was what it would change to, based on whatever that new joining fee is. How do changes to m in the equation f of x equals mx affect the graph of the equation? Remember, we talked about how changing the slope results in what's called a vertical stretch or a vertical shrink. Later on, you will learn that there's also horizontal stretches and shrinks, but those are going to be seen with other types of functions, other types of parent functions besides linear functions. How do changes in the equation affect the graph of the equation? If we change b, those are going to be a vertical shift. Another word that you may have used is a vertical translation. Like we talked about with translating shapes. You can translate a line up or down. Which parameter causes the steepness of the line to change for the family of linear functions? Steepness has to do with the slope. What are the different types of transformations? We have shifts and stretches. You can think of a shrink as a form of a stretch. It kind of fits into that category. So you can shift up or down, left or right. You can stretch vertical or horizontal, or shrinking is like the opposite of that stretch. The evaluate homework piece is up to you, and the key for you to check your work is posted in your Google Classroom assignments.